And I'm going to pass it to Lynn to introduce Professor Speck.
Oh, okay, I can do that. So it is my great pleasure to introduce Professor Angela Speck. And if you go to the next slide, you can see some things I found out about her by Googling. She is the department chair at the University of Texas, San Antonio. And I know for sure, this one I already knew, she's the chair of the AAS, that's the American Astronomical Society, which is the Society of Professional Astronomers, task force on solar eclipses. And she was all over TV during the 27 total solar eclipse. I personally saw her on TV on a number of different occasions. And this year, the next year's 20 total solar eclipse in 2024 will go right through Texas, also through Buffalo, where I'm from, and where Matthew is living near, and he's here now. So welcome, Matthew. Dr. Speck has also been a wonderful N3 mentor for the past 2 summers, so we really appreciate her participating in our program. And when she's not being a TV star talking about eclipses, she is studying dust from dying stars, and you can see the project she's done with her students on our website. So with that short introduction, I will turn it over to Professor Speck.
Thank you. Let's see if I can share my screen now. Go. Okay, so hopefully you can see my screen. Woohoo. Okay, so I'm going to talk about these eclipses that are coming. There's one this year, and then there's one next year. And even if you're not where you can see the total eclipse, you're going to get to see an eclipse. So I'm going to talk about why we get eclipses and what sort of things you can experience, and maybe convince you to travel to see one of these things. So let's start with the easy part, which is what causes an eclipse. Basically, we get an eclipse when the moon gets between the Earth and the sun. And so if you're standing on the right bit of the Earth, in this case, can you guys see my cursor? So if you're standing right here, you wouldn't be able to see the sun at all. It'll be completely blocked by the moon. If you're standing in this bit here, you'll still see part of it. So you have to be on the right bit of the Earth. But basically, we get an eclipse every time the moon comes between us and the sun. Now, to understand how often that happens, we actually have to understand moon phases. I'm sure you all have a pretty good idea about how moon phases work. I like this calendar because it shows you the moon phase for each month. So if we look at February and we go to today, you can see we just passed half full. It was third quarter or half full moon yesterday. And we're heading towards new moon, which is when we can't see the moon at all. But you can see that every month we get a day when we can't see the moon at all, and we get a day when the moon is completely full. I also like this calendar because you see where it's got a dot here or a dot here? That means there's an eclipse. So there's actually a solar eclipse going to happen in April. In this case, it says the 19th of April. But we won't be able to see it from the US. I'll talk a little bit more about that later. And then the next one that happens is in October, and that one we will see in the US. Okay, so let's talk about moon phases because it's important to understand this. So here I've got the Earth in the middle. I've got the moon going around the Earth. I want to point out that there are not 8 moons. It's just one moon put in different positions. And the sun is all the way off to the whatever side that is, right. So if the moon is in this position, we can't see it. It's still got half of it lit up. It always has half of it lit up, but we can't see the lit up side because it's pointing away from us. So we're standing on Earth, we're looking towards the moon, we can't see it. But the moon is orbiting the Earth. So as it orbits and it gets to this point here, now when we're standing on the Earth and we're looking at the moon, we can see just a small portion of the moon. And so we see a crescent moon. But the moon's going to keep moving because it's in orbit. And so we get to this point and now we can see half of the moon. But it's going to keep going and we're going to see more and more of the lit up side until it gets to this point when we actually get a full moon. Now, the moon is going to keep moving. So now it's going to get less and less of the lit up side is going to be seen until we get back to new moon. It takes 29.5 days to go from new moon through all the phases and back to new moon, or from full moon to full moon. Now, one of the things is when we look at it like this, and this is just a nice flat image, it raises a question. which is, well, hang on, if we have a new moon here and the sun is in that direction, why don't we get an eclipse every single time it goes through, every 29.5 days? Also, if the moon is here, how is the sunlight hitting it? Because the earth is in the way. And the reason why is we have to think in 3 dimensions. It's strange, but most people actually don't think in 3 dimensions. We live in 3 dimensions, but most people think in a kind of flat way. And so what you need to think about is, if you can see my face on the screen, if you guys are the sun and my face is the earth, then if the moon comes between me and you can no longer see my nose, right? That's because the moon would be blocking it. But most of the time, the moon is up above or down below, so it is not blocking. So I'm going to try and show that graphically. But basically, you can think of it as being the moon's orbit is at an angle. So most of the time, although the moon is in this position at new moon, it's in the direction towards the sun, it's not in a direct line. It's up above the direction between the earth and the sun, or down below. And likewise for full moon, which is why we can see it. So the way that that then looks is that most of the time, the moon is not lined up completely. So now the sun is way off to the right. And most of the time, the moon is either up here or down here, but its shadow won't hit the earth because it's not in perfect alignment. And likewise, we don't get lunar eclipses for the same every month for the same reason, because the moon is not lined up. It's not in the shadow that the earth casts. Just occasionally, and I'll talk about how occasionally, we get a lining up like this. Now, one of the things I want you to notice here is, if you want to see an eclipse of the sun, you have to be on this tiny bit of the earth here where the sun is completely blocked out. And so it's only a tiny bit of the earth. But if you want to see a lunar eclipse, an eclipse of the moon, the whole of this side of the earth can see it. So actually, lunar eclipses and solar eclipses are about as common if you take the whole earth into account, but you're much more likely to have seen a lunar eclipse because more people will see each one. More people on Earth can see each one. Basically, half the planet sees each one. Okay, so I want to bring together the orbit of the Earth and the orbit of the moon. So here I've got the sun, and the Earth is going around the sun, and the moon is going around the Earth. And the moon's orbit is at an angle. So you can kind of see that in this view graph here, that this plane is at an angle. The way you can think about this is, if the Earth and the moon are basically half sunk into a pond, so that you've got water and you've got a nice flat surface, then the moon's orbit is at an angle. So half the time the moon is out of the water and half the time the moon is under the water. So, and that's kind of shown here, where the moon at new moon is way above the water. It's above the direction, the plane of the Earth and the sun. And down here, it's way below. And so this is how it's going around. But because the Earth is orbiting the sun, as the Earth orbits, we get to a point where when the moon is in the direction towards the sun, it's also perfectly lined up. So at this point, we'll get an eclipse. But the Earth is going to continue moving. And so as it moves in its orbit around the sun, we're no longer in alignment until here we're really out of alignment. And then it gets back into alignment when we get round to the other side. So you can see here we get an eclipse at this point, and then it's not in alignment, an eclipse at this point. So that's twice in an orbit. So there should be an eclipse every 6 months. Actually, there is some sort of solar eclipse and some sort of lunar eclipse every 6 months, but not all of them are total, and not all of them can be seen from where you are. So let's talk about where you need to be to see an eclipse. So in this view graph, what I've got is, here's the Earth again, here's the moon, here's the sun. If you want to be standing on the bit of the Earth where you can't see the sun at all, you have to be on this little black spot. From there, the whole of the sun is blocked out. Now, if you're standing in this slightly grayer area, you'll see part of the sun. So you can see you're standing here and you're looking towards the sun. This part will be seen, but this part will be blocked out by the moon. So you get a partial eclipse in this gray area. But if you want to see a total eclipse, you have to be on this little black spot. But everything's moving, because everything moves in space. The Earth is moving in its orbit along this blue line. The moon is moving in its orbit along this green line, and the Earth is spinning. So one moment you have to be stood on this little black spot, but the next moment the spot's going to have moved because of everything moving. So it's going to draw out a path along the ground or along the Earth. And so it's only going to be as wide as this spot is, which is about 100 miles wide, but it could be 3,000 miles long. Now that sounds like quite a lot, but actually it's only about 1,000th of the surface of the Earth. So the chances of it being your bit of the Earth are pretty slim. And so to show you what that really means is, this is showing all of the paths of total eclipses. So where you need to stand to see a total eclipse for the years 2010 to 2060. So I don't know if any of you saw the total eclipse in 2017, but this is the path of the 2017 eclipse. This is the one that's coming in 2024. What I want you to notice here is that in a 50-year time period, most places on the Earth don't see a total eclipse. So most people are going to have to travel to see an eclipse. The other thing is that most of the places that see eclipses are ocean, because most of the surface is ocean. Remember I mentioned there's an eclipse in April this year. It's actually this path that we can see right here that goes over the Indian Ocean and into the Pacific. And the only bits of land it touches are basically a little bit of Indonesia, a little bit of Papua New Guinea, and there's a tiny bit of Australia. That's where I'm going to be in April, by the way. But you can see here, most of it, you'd have to be on ocean to see it. So we get one of these about every 18 months. Like I said, not all of the lining ups will give you total eclipses. We get a total eclipse about every 18 months, but you have to be on the right bit of the planet to see it. Now, I want to talk about what you actually get to experience during a total eclipse, because it is an experience that's not just visual. There's a lot going on. Now, first of all, what I've got here is, hopefully you can see that there's just a tiny bit of the sun apparently missing, and that's because the moon is starting to move in the way. And the moon is moving in the way, and it's blocking out more and more. And so before and after you have a total eclipse, you will have a partial as the moon is moving in the way. During this time, it is important not to look directly at the sun unless you have special eyewear. It is not safe to look at the sun. It will damage your eyes. But you should be able to get the glasses to do it. Now, no matter where you are, you're going to get some sort of eclipse, and I'll try and show you what that's going to look like for wherever you are. But this is what's going to happen is it's going to get darker and darker. But actually, until you get to about this point, so about 75, 80% eclipsed, you wouldn't even notice. If you didn't know, if you weren't looking to see the effects of it, you wouldn't even notice it. The sun is so bright that you don't really notice that change in brightness. Once you get to only having about 20% of the sun showing, you're going to start noticing that the colors are weird. It's a bit like the sun's already set. You know, the sun sets and it's slightly darker and the colors are weird. It's like that, but the sun's still there. It's still up. And the animals are going to start reacting because they notice that it's getting darker. And so what you're going to get is you're going to get to see some really interesting shadows. I'll explain this one in a second. And you're going to see things like birds. So whether you're in a city or the country, you know, birds do this thing around sunset before it gets really dark, where they flock. They get together in flocks and they do this flying around thing and like all together. And they do that at a certain level of darkness after the sun sets. Well, once you get to about 80, 85, maybe 90% eclipsed, the birds start doing that. They start flocking and they tend to tweet a lot. So it starts to get noisy. Dogs will start barking. If you're in the country or near a farm, cows start going back to the barn or lie down because they think it's bedtime. There's all sorts of interesting things that happen. In fact, there's even a case of in 2017, there was a study done that showed that bees react. And there's some studies that you could get involved with to record what animals are doing during eclipses. Now, I said I was going to come back to this one. This is actually the view under a tree. I want you to think about what it looks like when you're under a tree, you're in the shade of a tree and the sunlight's coming through, and you don't get a perfect image of the tree on the ground when you're looking at the ground. It's kind of dappled and messy, just on a normal day. And that's because each of the gaps between the leaves acts like an aperture. It's this little gap makes an image like a pinhole camera. And so you get lots and lots of images of the sun. So the sun is going to give you lots and lots of circles on a normal day. So you get lots and lots of circles overlapping. And so that's why what it looks like under a tree is all of this kind of messy light instead of a nice crisp image of the tree. Well, now it's eclipsing, and this one's a pretty far gone eclipse. You're at about 95, 96%. And you can see the sun is now a crescent, but it's making an image of that just the way it does every day, but now it's a crescent instead of a circle. So if you can find a good tree to stand under, you can have a look and see that and see it progress as the moon is blocking out more and more of the sun. You don't actually have to have a tree. If you've got a colander, you know, the thing that you use for straining pasta or vegetables, that will work too. Anything with little holes. In fact, you can even use your hands. If you hold your hands up and make little gaps between your fingers, you can actually make images of the sun on the ground, which is pretty cool. So I mentioned that there was this study on bees. Actually, what they showed is that bees stop buzzing once it actually gets dark. So they keep buzzing until it gets dark, and then when it gets dark, they all just stop buzzing. And then when it gets light again, they start buzzing again. This other image that I'm showing here, this is actually was a study on plants. This was in Wyoming, but plants will also react. If you've got flowers that close up at night, they'll start to close up as it gets darker. These plants actually started to take up less, water differently because that's what they do at night. Okay, so the moon is moving into place, but the moon is not a perfect smooth sphere, right? It has mountains and valleys and craters. So what you're going to see is as the moon moves into place, you're going to see these little bumps at the surface. You can see here we've got some valleys and some mountains and valleys and mountains. And so what you see is called Bailey's beads. That's actually spelt wrong. Bailey's beads are basically because these look like little beads at the surface. I'm going to show this in a little bit more detail here. So here you've got, there's still quite a bit of the sun showing. The moon is moving into place and it's starting to block it out. And as it blocks it out, you start to see these valleys and mountains, and you can really see this close up. And as you get to the end, you're just going to see a couple of beads, a couple of these valleys and mountains. Now, the other thing I want to mention about this picture is this red color you can see here. That's real. That's what the flares, and if you've ever seen pictures of the sun, like from NASA, and they have these big loops called prominences, and they have flares of gas coming off. It's not yellow, it's red. It's this color. And you can actually see this during the eclipse, which I'll show you in a minute. Now, the last thing you're going to see is the deepest valley, right? You're going to have one valley that's in the direction that the moon is moving. That'll be the last bit of sunlight to come through. And what you see looks like this. So you've now blocked out enough of the sun that it's dark enough that you start to see the sun's atmosphere. The atmosphere is always there, but it's really hard to see it because it's so faint. It's only about as bright as the full moon, and the sun is so bright that you just can't perceive that faint glow. But at this point, you've blocked out enough of the sun that you start to see it, but you can see a really bright bit where the sun's light is still coming through that deepest valley. And this is the last thing that you see before you hit totality, the total eclipse. This is what a total eclipse looks like. This is a real image taken in Oregon in 2017. Now, I was in Missouri in 2017. It looked exactly like this. You don't need anything. You don't need any special glasses. You don't need anything at all. You can just look at it. What I want you to notice here is, remember I said about the red, you could actually see these little prominences that you can see here. I could see those with my eyes. I didn't need a telescope. I didn't need anything. I could just see them. It's amazing. The other thing that I want you to notice here is this is a star. It gets dark enough that you can see stars, okay? But there's more going on than just being able to see stars and planets. It's also going to get colder. You just blocked out the sun. Think about what it's like on a sunny day when a cloud moves in front of the sun and it gets colder. Well, it's going to get a lot colder. It can get 10 degrees colder as the moon moves in the way. And so it got colder. But because it got colder, it also changes the air pressure. So you get wind. So it gets breezy. And then you've got the animals. If you've got animals around you, they're going to start making noises. The birds, actually, they've been making lots of noise up to this point, but now it's dark, it's bedtime. They all land and go quiet. If you have people around you, people will be wailing and crying because it's that impressive. Okay. Now, one of the things that's really cool is if you can be in a place where you can see like all the way around you. I know that's hard if you live in a city, but you can actually see a really interesting effect. So I want you to think about what it's like at sunset, and the sun's setting in the west, and you can see sunset colors. But if you look to the east, it's already dark. Well, now what it's going to look like is the dark is up near. So you've got this bright bit here that's about as bright as the full moon. You've got some stars, but this is as dark as it's going to get up here. And as you move your eyes away from where the sun is, it's getting lighter and lighter till you get to the horizon, and it's sunset colors, but not just in the west, all the way round, all 360 degrees. Now, a total eclipse can last anything from a few seconds to up to about 6 minutes. Normally, more like 2 to 3 minutes. So you've got 2 or 3 minutes, and in that time, you want to take in this hole in the sky and this beautiful thing that is the corona, this glowing atmosphere, and the stars and the planets. And is somebody crying? And what are the animals doing? And oh my God, it got cold. And there's a breeze. And oh, look at the horizon. And then it's over. It is one of the most life-changing experiences you can have. And it's not like anything else you will ever experience. And you cannot experience it unless you go to the path of totality where you can actually see a total eclipse.
Which continents are total eclipses visible?
I will show you a map in a minute, okay? Now, I want to talk about this just briefly. So if you've heard, you may have heard of the supermoon. There's a supermoon every year. Basically, it's when the moon is biggest and a full moon at the same time. So, when you have something that's close to you, it looks bigger, and you move it away from you, it looks smaller. So if I put my hand closer to the camera, it looks bigger. If I move it away, it looks smaller. Same with the moon. Its orbit isn't a perfect circle. So when it's at its closest point here, it's going to look a bit bigger. When it's at its furthest point, it's going to look a bit smaller. Now, because of the way the Earth also orbits the sun, although it goes through this point, perigee is the closest point to the Earth, although it goes through this point, every time it goes around, that isn't a full moon every time. So supermoon is when the moon is going through this point and it's a full moon. Now, if that happens and you have a full moon, then that means that when you get to new moon, when the moon is at the other end of the orbit, the moon is at its smallest. And if that happens, the moon isn't big enough to block out the whole of the sun. It gets a little bit more complicated because actually the Earth's orbit is also not circular. So we're actually closest to the sun in January and furthest in July. So depending on where we are in our orbit, that will determine how big the sun looks. And depending on where the moon is in its orbit, that will determine how big the moon looks. And so if there's a mismatch, you might not get a total eclipse. Remember, I said there's a lining up every 6 months, but not every one of them will be a total eclipse. And so we get what's called an annular eclipse. And this is what it looks like. You look like you've got a hole in the sun. So you still get a partial as the moon is moving in the way, but when the moon gets between us and the sun, there's still the edge of the sun showing. Now, when this happens, you don't get all the cool stuff I was just talking about. You don't get to see the atmosphere. There's just too much light from the sun, but it's still really cool to see. And this is what's going to happen in October, and you will be able to see it from some places in the US. And I'll show you a map of that in a little while. So we get annular eclipses and total eclipses depending on where we are in our orbit and where the moon is in its orbit. So here's a map of all of the eclipses from 2021 to 2040. So the question was, which continents? They happen everywhere. The red lines are annular eclipses and the blue lines are total eclipses. So remember I said I'm going to Australia? That's this one right here. And you can see it's actually very skinny. It actually transitions from being, it's an annular eclipse, and then we get just a little bit closer to the moon, or the moon gets a bit close to us and it blocks it out, and then it it gets a bit further away. So we end up with a nice total eclipse right here. Now, the important thing here is X marks the spot. You can see that we have, this is in October this year, October 2023. We will get an annular eclipse that you can see from this area here. So it's mostly Western states. And you've got a total eclipse that we can see from Mexico, a large swath of the US, and up into Canada. Are most of you in the New York area? No, you're all over the place. Okay.
No.
There's lots of Californians and lots of New Yorkers and a few people in between.
Okay. Then I'll try to point to, you know, a few different places. So so here's where those two cross. Now they're 6 months apart, but the annular eclipse is in October this year, and then the total eclipse is in April of next year.
How lucky for you.
And yeah, and I live right
know,
about where
yes.
that little, right about, actually right just a little bit below that little the I-10 sign right there.
When you took the job in San Antonio, did you know about the eclipses, or was it just totally unrelated?
I knew about it, but it wasn't a motivating factor. But it was definitely an added bonus. So, you know.
Yeah, that's so cool.
But let's look at where other people will get to see things. So this is for the annular eclipse. So remember this one, you don't get to see all the cool stuff, but it's still pretty cool. So you can see, here's the path right here. So if you're between the red lines where the little dark circles are, you'll get to see an annular eclipse. But if you're not there, so for instance, for those of you up in the New York area, you'll get an eclipse that's around 25%, something like that, okay? So it's going to look something like this, which is still kind of cool to see. If you're in the San Francisco area, you're going to get a 75% eclipse. So that's going to look more like this down here, okay? So depending on exactly where you are, you're going to get different levels of this. So you can see here in St. Louis, I used to live in Missouri, they're getting about a 50%. So you can see how much is being eclipsed, and it depends on how close you are to this path, okay? So you get the idea. But everybody in the US is going to get to see a partial eclipse. Just depends on how close you are to this path, how much of an eclipse. But this is the path for the total eclipse. So here you can see it goes over Mexico, over the US, and up into Canada. And I heard Lynn talking about being from Buffalo. You can see Buffalo is right on the line.
Yeah, and I'll be going to Buffalo, but of course the weather in Buffalo is terrible. So
I will
have to go
show
because
you.
my family's in Buffalo.
Yeah. And I would recommend, honestly, if you, no matter where you are, if you can find a way to get to the path of totality, it is totally worth it. So I was lucky that in 2017, I lived on the path of totality in Missouri. In 2019, me and my mom went to Argentina because we wanted to see another one. So it's totally worth trying to get to somewhere that you'll get to see one, okay? But even if you can't do that, because, you know, a lot of people can't, if you're in that New York, Philadelphia area, you're going to get, you know, almost 90% eclipse. So it's going to look pretty cool. It's going to look, you know, like this really thin crescent, like we were saying under the tree.
I think I'll be able to get to the path of the totality for that April 8th one in 2024, because I'm pretty sure, because my parents have like a full-on van, and even if I have, even if that isn't a weekend day, I'm pretty sure I can convince my professors to let me, you know, I can just eat the day, like eat a few days of school
it's
off.
a Monday. It's a Monday.
It's a Monday.
So, yep.
Yeah, so I'll just
probably
eat the week
skip
or
a day.
something. Get you know, get ahead for that week, and then go up, convince my parents to drive us up to Buffalo so we can see the totality, or, you know, go up
Excellent.
in that area.
I told you I'd be convincing you. But as Lynn said, this is the estimated cloud cover. So as you are up in Buffalo, and this is just an average. This is taking an average of cloud cover for a time of year that's very close to the time it'll be, and over a lot of years. And you can see up in Buffalo, it's right up at the 60 to 70% cloud cover. Where I live down here, it's down at the 30 to 40%. It's April. We get clouds in April. However, I will tell you that I was in Missouri for the eclipse in 2017, and we were estimated to be at the 55-ish% level. I saw the whole thing. It really depended on exactly, some people in Missouri saw nothing, and some people saw the whole thing, no problem. So it really depends on, you know, this is only an average. It doesn't mean it's really going to be like that. The other thing is those breezes that I talk about, sometimes they will clear out light cloud. If it's heavy cloud, you're done for. It will still get dark though. It will still get dark and the animals will still react. So it's still a cool experience. But if it's light cloud, the breezes can actually blow them out of the way and you can still see. So, oh, I didn't update those days. Okay, this is out of date by like a week. No, not even a week, 5 days. So here we have the annular eclipse. It's in, you know, 260-ish days, and the total eclipse is 440 days, and you need to get to at least see this one. And I'm going to stop talking and let you ask me questions, but just in case you want to find out more, this is the American Astronomical Society's eclipse website, and it has all sorts of information on it.
Well, thank you very much. Do we have some questions? Yeah, please put them in the chat.
Or you can use the little raised hand feature on Zoom. We can do like 5 minutes of questions.
Yeah, I totally agree with that XKCD cartoon. Yeah, it was pretty amazing, especially because we happened to be at a place that had horses and I have horses at home. And so I was really watching the horses to see how they would react. And it was, to me, it was, I just thought it was fascinating. Because they really thought it was nighttime. They all stopped eating. They started to go towards the barn. And as soon as it was over, 2 minutes later, they all came back out and went back to eating.
I like Ariana's idea that we should get you should get N3 eclipse glasses.
Why not?
Well, because I think NASA's already printing a whole bunch.
That, yeah.
Could have our logo.
Exactly. I mean, I'm going to have some of the, because the NASA ones are going to be NASA and NSF and NOAA and AAS. So the co-branding. But I have Roadrunner because, you know, that's our mascot down here at UTSA.
I took one of those at the Eclipse conference, so I have a UT San Antonio bear.
Excellent.
I took a few. I've been collecting them.
Nis,
Does anybody have any questions for our speaker? Be nice to put them in the chat, or
I think Nis said he saw the 2017 eclipse. Where were you? I know you said your grandfather's, but where?
He lives in North Dakota, Garrison, so like the lake in the middle of North Dakota. He does a lot of metalworking in retirement, so we taped. So what we did was we cut a hole in some pieces of cardboard and then taped a piece of welding glass into that so I could look directly at the sun through that without getting eye damage.
Excellent.
So that was pretty cool, but I think, you know, the one coming up in 2024 is going to be even more crazy because, like, yeah, total, and it'll be right there for me.
Exactly.
okay. Well, we don't seem to have a lot of questions, but I'm sure if some come to you later, you can send them to us and we can send them to Dr. Speck.
You're an expert at presenting about this, Angela. No questions.
I've had a lot of practice.
Yeah, you sure have. That was
All
just great. I learned stuff. I love it.